for the first time in a long time, people's individual leverage has been exponentially multiplied. Expose yourself to as much of like AI and research as possible, but really focus on your unique ability as a human to be creative and discern like these cool things with all the context that you have. There were more interesting problems to solve than the ones we were able to solve in our PhDs. We wanted to train models that allowed people to at least give them the option to control their own intelligence rather than relying on the big labs.
You went from Australia to San Francisco. What was that like?
Yeah, it was a bit of an arduous journey to get here. So I did undergrad in Australia, then was planning on doing my PhD at Oxford, which is where I met Moody through my best friend Max, who was also at Oxford. And then we decided that there were more interesting problems to solve than the ones we were able to solve in our PhDs. And we took a temporary leave of absence from Oxford. Moody jokes that I'm not a proper Oxford student because I was only there for realistically only a few days. But yeah, we decided to have a crack at a startup and we gave it a year to work. And originally that meant building out of London because like that was where everyone's home base was, very close to Oxford. And I think at some point we realized that the serendipity of SF and like just the surface area of your luck here was a real thing. And you know, you hear it over and over from so many people, but it's a hard thing to grasp and come to terms with until you've actually been here. And so I think, yeah, on a trip to SF, after the company had been around for a few months, I think more things happened in 4 days than had happened in the previous, 4 or 5 months. And we sort of thought, okay, it's completely irrational to not be here in the epicenter of where everyone's building. And yeah, so we moved the whole company here. We told everyone that we wanted to be in person in SF, and fortunately everyone we'd hired thought that was the right decision, and everyone moved over within, I think, about 2 weeks, and we moved into a hacker house with all 8, 9 of us. And yeah, that went from there.
What happened in those 4 or 5 days? You mean you just met a lot of people?
Yeah, I think a combination of meeting customers, meeting people that I had looked up to for a long time, and like just not only like seeking them out, but also just like literally running into them at certain events. And I thought, okay, wow, like there's just so many like interaction effects and network effects here that you'd be kind of stupid to ignore. And yeah, as soon as we moved here, I think things really started to kick off for Parsed, which was our startup before we joined Baseten. And like, it's really easy to like crystallize your vision and where you're headed as a company when you have so much more information being poured in. It's very hard to make that or do that analysis in a vacuum and thinking through like, okay, where do I think this field is going to be headed and how can I position the company to best take advantage of that? To do that in London is very hard because you're not receiving this influx of information from all these different people with all these different opinions. And you're not able to integrate over all that as well.
Yeah. I want to go back to your time at Oxford, like briefly, and tell me more about like what factored into your decision to leave.
Yeah, I think it's a PhD versus industry has always been a question. It's not like this has just come up with the advent of AI. I think a lot of people who are both very intellectually curious but also care about the impact that they can have on the world grapple with this when they're deciding whether to go to grad school or not. And it's an age-old joke about, doing PhD and being a poor grad student versus, going off and joining big tech and making the money. But for us, it was really about, for the first time in history, I think the impact that an individual could have, or at least a very small group of people, had been multiplied and leveraged significantly more than it ever has been, certainly in my lifetime and for quite a long time before that. And so I think the calculus shifts a lot. You have to decide whether you're going to narrowly focus on one very small edge of the periphery of the scientific bubble that you're going to try and advance, or whether you take a step back and go, okay, I'm going to take a little bit more of a risk here, but I'm going to tackle a problem which, if I solve, could potentially be much bigger and much more impactful for the world. So I think all three of us, Moody, Max and I, felt that. We knew there's advantages to having very like academic roots and research-based roots. And in some ways that was a big advantage for us compared to a lot of the other startups. But yeah, I think the temptation to solve a bigger problem than we could at Oxford alone was just too much to ignore.
Mm. What do you think was the advantage of the academic route that you talked about?
When you're in a startup, you often operate in this mode of like greedy action selection, right? So every day you're trying not to die, and it's very easy to get very myopic and say, okay, what is the thing I'm going to do next, which is going to maximize revenue over the next week or the next month or whatever it is. Mm-hmm. Whereas like in research, I think you have to develop a lot more of this longer term strategic planning ability. And you have to be able to say, okay, like is the thing I'm doing now going to be something that if I weren't going to do it, someone else would solve? And to me, that's not a very interesting problem. To most researchers, that's not a very interesting problem. The best researchers are the ones who can say, okay, if I weren't going to tackle this, like probably no one else would tackle it in the way that I might go about it. And that would be a bad thing for the world, because I think that this is a solution that should exist, or an area I should push on. And I think like with Parsed, to like give a concrete example, like we knew that post-training as a service, which is what Parsed did, would eventually become commoditized to an extent. But we also knew that like the ways in which people would try and commoditize that would be different to how we would go about it. So everyone was very attracted to, verifiable tasks and like these very deterministic tasks, so that they could focus on the purity of the engineering and algorithmic problems. And people who like RL tend to like that kind of pure maths problem space. But we thought like, okay, no one's really going to go after these non-verifiable areas like legal and medicine and insurance and things like that. And we knew that solutions wouldn't exist as quickly as if we went in and tried to tackle that. And so to us, like having that kind of long-term thinking, and ability to select a problem which you have a unique position to tackle, was like, really enticing to us.
I want to talk a little bit more about the PhD question, because I feel like a lot of people think they can't really become like an AI researcher, for example, without a PhD. And I'd love to like hear more of your thoughts on that for someone who believes this or is thinking about this.
For the first time in a long time, like people's individual leverage has been exponentially multiplied. And I think this is very much the case for research. This is a useful analogy to me when thinking about like the type of stuff that I want to be working on. There's like basketball players who like every single play that you do, you have to hustle, and you have to be doing like a lot of individual, very little things, right? And I think like traditionally, like a career has looked a lot like a basketball player. Like you work to develop a set of skills and push to become like, top 10% in a skill that a lot of people have, so you can make a good career out of it. And I think the world is now shifting with LLMs, because we now have this setup where if a lot of people can do this skill like reasonably well, that's the basis for the training distribution or the RL environment that is going to allow language models to do that. And so I think now people are shifting towards like needing to be more baseball players, where you might not do anything for a really long time, but you have to be able to like kind of hit the home runs. And so like from a research perspective, that's like what I would be focusing on, is like, not can I like ingest all this like, knowledge and history of the field, a lot of which has become irrelevant with how quickly language models are moving and how much that field has evolved in such a short period of time. It's more like, can I develop like the metacognition skills to be able to say, okay, again, what is the research problem that I want to work on? And can I hit a home run every once in a while that like a language model is just not going to have the creativity to be able to come up with in the first place, or even if it does come up with it, it's not going to have the value function to be able to discern that that is a good idea amongst the many, many millions of ideas that they can generate. And so, yes, like expose yourself to as much of like AI and research as possible, but really focus on your unique ability as a human to be creative and discern like these cool things with all the context that you have, and not try and, start from this bottoms up layer of like, I'm going to learn, matrix calculus, and then I'm going to like step through that, and then eventually I'll build a neural network, and then eventually I'll train it, and then eventually one day I might get to LLMs or diffusion models or whatever it is. I think the world is going to reward researchers and people in general who are much more top down. It's like, okay, here's this cool idea I have. I have no idea how all these intermediate bits work, but I'm going to get the thing working. Then we're going to fill in the skill tree on the way down, rather than going bottoms up.
Yeah, that's really interesting, because I feel like that's not really how we're taught to learn, right? Like in school, you just start from like the ground up, and then you work your way over time.
Yes, I like completely agree. I think like I have a lot of qualms with like how things like maths and stuff are taught in school in general. But yeah, like so many of AI researchers and people getting into AI research are very predisposed towards, the Andrew Ng, and I love Andrew Ng, but like his style of course is very much, you learn the very basic fundamental building blocks and you slowly step your way up. I think someone who does this really well is Jeremy Howard, and he's like actually one of the first people that I started like learning AI from through his like fast AI stuff. And his whole thing is like, okay, the first thing you're going to do is train, back in 2018, it was like convolutional neural nets. But he's like, okay, I'm going to give you the stuff so you can train a convolutional neural net in like 4 lines of code. And then over the course of like you learning about it, you're eventually going to work your way down to be able to write that from scratch yourself in like raw PyTorch. And I think for me that like allows you to have so much more velocity, but you need to be comfortable living in a world where you don't know everything, and like focusing much more on intuition and creativity as opposed to like how you would normally build up a skill like maths, which is like filling out the skill tree from the bottom.
So like if I'm learning a new hard topic like RL or something, don't know much about it, but not starting from like, okay, what's the thing, like 12 levels beneath it, like ground up learning, but just starting like at the top.
Yeah, like if I wanted to learn RL and be the best at RL, the first thing I would do is grab an open source framework, and I wouldn't touch a single line of code. I wouldn't read a single line of code except for the config.
Yeah.
And I would try and plug that into some arbitrary environment. It might be an environment I've written. It might be like a standard maths environment. And I would watch that curve go up. And then once I got that curve to go up, I'd maybe change a couple of these, hyperparameters and say, oh, okay, like that's how like the group size affects this curve in this way. And then I would slowly work my way down the code until like I fundamentally understood, okay, this is the GRPO algorithm. Here's everything that's wrong with it. Here's what we fixed with the length normalization bias and dividing by standard deviation and everything. And I'd develop that. And I think if I did it that way versus, starting from, okay, I'm going to learn, policy gradients. I'm going to go back and read Rich Sutton's textbook and work my way through the history of RL. So I fully understand everything before I run my first GRPO loop. I think the former case beats the latter case like every time, and you become a much better researcher because of it, and a much more practical researcher as well.
Yeah. The latter case seems not as motivating either.
No.
Right? It's like, I want to learn about this thing. Okay, I need to go learn 8 other things that are at a more basic level. And then in 6 months, I can actually learn about the thing.
Yes.
Yeah.
Yeah, you need that dopamine hit of, watching the curve go up.
Yeah. I want to hear more about your advice for other people who want to become researchers.
People often give wishy-washy and like abstract advice. I think maybe the most useful thing I could say is like grounding this in like how I am currently thinking about research. So I think like you of course have to have enough context and enough knowledge of the field in general to be able to have some sort of refined value function over what good ideas are and where the field is headed. And for me, like if I sit back and think about like, okay, what are the most interesting ideas to me personally, to the field, and to like me in the context of, for instance, Baseten, which cares about inference and open source models and an ecosystem of these specialized open source models, then the kind of thing that sits at the intersection of all that for me is like continual learning. And it's not continual learning in the way that the big labs care about it. It's continual learning for very specific tasks in specific jobs and domains, much like you might have a human who's doing a specific job and needs to continually get better at that job. Whereas the big labs care more about, okay, we have this very general model, we would like to generally update this distribution with the last 6 months of internet data. How do we do that without forgetting anything? So first off, I'm like, okay, that's an interesting problem to me and to everyone in general. I think it's an interesting problem to like Baseten in the specific context I'm in, because we have a unique, like potentially more tractable way to tackle this question than someone like OpenAI or Anthropic does, because we just care about continual learning for like these specific jobs, for this model that is going to be a lawyer, or this model is going to be like, a medical note writer or whatever it is. And then I say, okay, like I've got my kind of first principles axiom of where I think the field is headed. Like, how do I work backwards from that to construct a research agenda that is, 1, going to be tractable, yes, but like 2 is actually going to push in the direction that I care about. And so first thing I think about with continual learning is, okay, the big limitation to continual learning at the moment is the context window of the model. Like the model is perfect up until, 200K tokens or a million tokens. But outside of that, it just falls off. And so how do people currently solve this? We have these like markdown memory systems. We do have people on the other end of the spectrum actually trying to extend the context window, but that gets very hard. Like you can't really get around the quadratic complexity of attention. And so to me, then I think, okay, as a researcher, like what is my unique approach going back to this? Like if I went to do this, what would no one else do? Like what would my unique approach here be? And to me, that's like, okay, can I extend the context window by sacrificing some of the losslessness of the KV cache or the context window for more context window? So can I learn to compress everything that's come in the context window so far so that I can extend it? And so then, okay, we've got our axiom, we've got our first step, which is like, I would like to be able to compress the context window. How do we do that? And so this kind of led to our research with like neural KV cache compaction. And then it's kind of easy to start to chain these steps together beyond that as well. So you then say, okay, I have some sort of compaction mechanism. Now my context window is not 1 million tokens, it might be 50 million or 100 million effective tokens in my context window. How can I train the models with this compaction in the loop so that they're much better at it? And then that leads to another natural like step in the sequence, which is, RL with compaction in the loop. You even give the model access to a tool so it can call and compact its own context window. And then that's really cool to me. And then finally, like, okay, I've got all this context sitting around. Again, going back to the main goal or axiom, like if the model is repeatedly using this compressed KV cache, I probably should just put it in the model weights for this specialized model. So how do I go from compressed KV cache to, I don't know, I learn a hyper network to project it into LoRa adapters or something, and then put it back into the model weights? And like, that's a very concrete example. But like, that is how I kind of think about, like, you know, first off, think about where you think the field is headed. Think about the intersection of what is an interesting idea to you and an interesting idea to the field that's going to be useful to both. And then can you construct a research agenda in a sequence of, like, you know, a through line through that kind of axiom that would allow you to make meaningful progress on it.
Yeah. I have so many questions from there, but one thing I was thinking about, you mentioned as a researcher, you need your own unique point of view. How do you think someone starts to develop that, like when they haven't had much practice yet?
Yeah, it's hard because like you can't like retrospectively go back and change your life, right? And I think some of the best researchers I have that I've seen have just this unique experience that like somehow gives them this different worldview from everyone else. And I think this is in the age of LLMs, which are very messy and not the pure type of, you know, IMO intelligence that you might expect people to might be a traditional indicator of success or correlated with success in more quantitative fields. I think that people with this unique experience often do so much better. I think like one of the things that I've found has helped the most with me is like my background is mainly like, you know, philosophy and literature. I started out in law and philosophy. I did that for quite a while at university. And I think that, yes, like quantitative intelligence is very important, but like for me in particular, I guess my like unique skill vector is like I love language and I love the messy world of language. And I think that I'm very comfortable operating in a world where language models aren't these like deterministic algorithms that you can solve with like logic circuits. They're messy real world things that have this behavior you need to shape. And so I would just like encourage people to think about like what is their unique skill vector that allows them to tackle problems in different ways. And I think there's so many examples of this. Another Australian, like Sholto, I think like one of his unique advantages is like what he learned through his fencing career. And I think he's talked about this a fair bit. And he has this sort of great line about, you know, one of the things that taught him was that most researchers focus on training only. And by training, I mean like in the analogy of sports, like preparing for a tournament or a game or whatever it is. And he said that what fencing really taught him was that like no matter how much preparation you do in training wise, it doesn't matter if you're also not devoting a significant a portion of time to performance. Like when you're actually in the minute of the game time, like how are you performing and how does like your psychology and preparation and everything prepare for that? And I think like that's a really unique skill vector, right? Like not many AI researchers have been world-class fencers, and to be able to learn that allows you to, you know, go in and do research and like, yeah, obviously focus on the training, which is like you're reading papers and you're absorbing information and all this sort of stuff, but the performance side of things. So like when you sit down to actually do research, are you treating this like an actual game that you are now playing? And it's high stakes in that sense. So yeah, like people should think about what, and everyone has this, I think, but not many people leverage it as much as they should.
Yeah, I don't think we do leverage it. Yeah, it's not also what we're taught, I think, in school, traditional school and things like that. Yeah. I'm also curious, so you said that you were studying philosophy and then you switched to AI.
Yeah.
Can you tell me how this happened?
Yeah. So actually, I wanted to study English literature when I went to university. My mum was an English teacher for a bit, and she's always been very big into reading and got me into reading at a young age. Career advisor convinced me to do law instead because they thought it was a safer career path. And as an 18-year-old, I just kind of went along with that. But yeah, wanted to do philosophy as well. So I think I just love the humanities and reading and writing. I didn't necessarily enjoy the law as much, but like loved the philosophy. And philosophy got me into Gwern, which is how I found, I think it was the GPT-2 paper. And Gwern had written a little bit about, you know, scaling laws, even back in the GPT-2 days. And then I went and found the original GPT paper and was like, wow, look at the difference between these two things. And all we scaled up was like the data and the model size, essentially. And I think like for the first time, like that quantitative world of deep learning and maths and stuff, which hadn't really necessarily interested me before because it was so pure and well constructed, became really interesting because you were suddenly trying to approximate human language, which like, you know, Chomsky and all these others have said it could never be done. And there was early signs of life there. And so that was the most interesting thing to me. I think that delta showed me that like, you know, when GPT-3 would eventually come out and GPT-4 and GPT-5, like if that delta kept up, then this would probably be something that a lot of people would be talking about in 5 or 10 years. And then decided to throw myself into like language modeling, basically swapped to pure maths and computer science. And fortunately, that bet paid off and the scaling laws stuck. But yeah, it's, I guess, thanks to Gwen's philosophy and clicking on a few random hyperlinks around Gwen's blog that got me into language model.
So then you started studying math, computer science, and went from there.
Yeah.
Okay. And then how did you come about like co-founding Parsed?
Yeah, I was always very much not interested in being a pure academic. I was also not interested in just like going straight into industry. Like I liked sitting on the line in between those two things. So during undergrad, my mate Max, who I eventually co-founded Parsed with, we had a small startup doing news debiasing with language models. So we'd set up this big scraper to scrape the internet every day and aggregate all the news stories and then like try and use a language model. And these were really bad language models to like write a debiased version of that story, like stripping out all the sort of fluff around the periphery so that people could read
so it was
unbiased
like
news.
AI journalist?
AI journalist, exactly.
Unbiased?
Yeah. Very difficult to sell to VCs. We then tried to make it a two-sided marketplace where like journalists could contribute information that would go into the algorithm and consumers would read it. We knew nothing about VC or what businesses would scale or anything like that. It was just a really cool idea to us. And we had a lot of fun building it, but like I think I really got that itch. And even though it didn't really succeed in the end, like it eventually morphed into this, large scale like RAG enterprise thing that we ended up selling to a few enterprises. Like I got the itch and I saw that like you really could just tackle problems, and like particularly with LLMs, like there were just so many problems that you could tackle now that you couldn't have made a dent in before. And so I was like, I would love to tackle the biggest one that I can within my capability. And I don't think that's purely in academia, but I also think that like the research background enables you to tackle or like creates a bigger set of problems that you can tackle once you have that experience. So
you said you got the itch.
I got the itch.
To go find a big problem and solve it.
Exactly.
Okay.
Yeah.
Okay. So then how does that lead to Parsed?
Yeah. So that kind of finished. I was like, okay, I probably need to like, it seems a bit hypocritical based on everything I've said so far, but I probably need to like go and do a PhD and like figure out what these problems are and develop my skill set more and this sort of stuff. And so, I applied to Oxford, was very lucky to get Jakob Foster as a supervisor, who is like one of the best at, meta learning RL, multi-agent RL, and was just trying to find interesting problems to work on. And then I think within 45 minutes of having met Moody, Max introduced us at a pub in Oxford. We were all like realized how much of the itch we all had.
Yeah.
And it was a pretty easy decision after there. In fact, Moody and I and Max started the company after I'd spent 45 minutes in person with Moody.
So you were at a pub and you all kind of hit it off as friends and started talking about like what you're building.
Yeah, well, not even what we were building, just like what we thought was missing from the world that no one had built yet. And Moody, I feel like we all had these unique perspectives. Like Moody was going to be a neurosurgeon. He was very interested in applying AI to medicine in some form and felt like it was very underleveraged there. Max was doing neuroscience as well, but more like computational neuroscience, and like was very interested in how the brain worked and thus how LMs worked and the parallels. And then I had my own background, and like I feel like you really appreciate that unique perspective in other people, particularly when you converge on like caring about similar problems. And so they just felt like the right people to start the company with.
I like how you guys all have like your real names and then like nicknames.
Yeah, this is a very Australian thing.
Chuck,
yeah,
and then Moody.
Yeah.
I'm still learning all the nicknames.
Yeah, I feel like I say like Kirks and people are like, who's that? And I was like, oh, Max. And they're like,
I was confused about
Max.
that for a second. I was like, wait, or Chuck. I was like, oh, Charlie's Chuck. Okay, makes more sense. Yeah.
Yeah.
So talk more about like finding the problem of Parsed. Like what does Parsed do?
So originally we set out and we thought, okay, we're just three like idiots basically. Like this probably isn't going to work. Like we're going to have a crack. It's not going to work. Like no one's going to give us money. Like we'll have a crack. And we went out being very honest that we didn't have a very concrete idea. Like I think we had a meeting with, it was Lightspeed, I think. And we were originally trying to narrow ourselves down to this very confined like AI for like hospital use case like thing. And it was like 8 hours before the meeting and we were like, this is the stupidest idea in the world. Like we don't care about this. Like we've tried to pigeonhole a solution that we think the VCs would care about. Like let's just go in and basically be honest and say like, okay, here are the things we're best at. Here's what we think is missing. We're going to try and do blue sky research to try and converge on like the exact problem we want to solve with the skill sets that we have to solve it. And then that worked really well. And we raised like a seed round, and then pretty quickly converged on the idea of, you know, the world of big token where everyone was calling generalist closed source models was not necessarily either the world we wanted to live in, but also like an efficient allocation of resources, really. Like we really thought people should be specializing their own models. And so we were very early to that idea, and it was quite contrarian. But we were like, okay, we're going to fully lock in on post-training, which is what largely my background had been in, and figure out how do we get people from, you know, Opus 4.6, wasn't Opus 4.6 at the time, but an Opus 4.6 frontier model to a specialized RL'd open source model for their task, and how do you like make that better over time? And I think there's a lot of grinding and gnashing of teeth as you try to convince people that this was possible, but kind of halfway through last year, I think people started to come around to the fact that open source was now, the base open source was now in a place where you really could post-train it and deliver results and quality that was above and beyond what the frontier models were giving for a specific task.
I've kind of asked you this before, but I want to talk about like big token. What does that mean for someone who's listening and they haven't heard this yet?
Yeah, I think maybe like Moody likes to say that we came up with it when I put it in a blog post once. I think people have said this for a while, but big token is essentially this idea that like, you know, one or two frontier labs are going to be the owners and controllers of AI and like any useful AI. Like open source will never be able to keep up with the advancements in the frontier inside these closed source labs, and big token will rule AI in the same way that like big tech has ruled tech, and a handful of companies are going to basically steer everyone's destiny with that. So like we didn't necessarily think that, even just from a philosophical point of view, that that's the world you want to live in. We were much more, originally it was little token, but I feel like little token is a bit demeaning. So we started calling it like democratized token or something like that. But we really thought that we didn't necessarily have to just buy into this narrative that Anthropic was definitely going to win everything. And I think Anthropic's a great company and they're going to be around for a long time.
Yeah.
But yeah, like we wanted to train models that allowed people to at least give them the option to control their own intelligence rather than relying on the big labs.
Mm-hmm. So for someone who doesn't know much about open models yet, how do open models really like enable you to control your own intelligence?
Yeah, so the thing you can do at the moment with open models that you can't really do with closed source models is specialize them. And so, of course, like most people, and we even recommend to most people that you start out with closed source models and you prompt them and you set up your scaffolding so that, you know, you can actually do your task in the first place and confirm a language model is at least in the ballpark of being able to do this thing. But at the end of the day, you're going to reach a ceiling of capability that you can get with prompting. You've got to remember that as good as these frontier models are, they are trained on a whole distribution of the internet and then a whole bunch of RL environments, 99.99% of which have nothing to do with the task you're trying to do. Of course, you need a certain like base level of intelligence and world model in order to be able to do the task. But you are going to eventually hit this ceiling with what you can do with prompting and scaffolding and agent harness around a closed source model. And then once you realize that any of your competitors, so if you're trying to build, you know, a medical scribe or, you know, a legal redlining agent, you've got to realize that if your competitors are using the same model and wrapping the same model, then they're also going to converge on that ceiling, that, you know, 80% of task performance or whatever it is that you can get with prompting a closed source model. And so then you start to say, okay, well, what is my only advantage here? And maybe it's not even your competitors as well. Maybe it's, you're actually worried about Anthropic. I know that a lot of startups in the last sort of even few months have realized that, you know, if you're doing PowerPoint generation or Excel or whatever, like Anthropic is very explicitly including this in later rounds of Sonnet and Opus training. Like first it was Excel, then it was PowerPoint. Now they're going after general computer use. And so if your startup is just a wrapper around Opus 4.6 with a few prompts, then you're very susceptible to Anthropic eating your lunch. And so they sit back and they say, okay, what is the one advantage that we have over Anthropic? Well, it's like the real world data and the real world signal that would allow me to get better at this particular task and make a model better at this particular task. Mm-hmm. And the only way you can really do that and have control over that at the moment is through training an open source model. And so what that looks like concretely is, okay, first off, people will tentatively dip their toe in the water, and they might come to someone like us and say, look, okay, we have this data, we have this like signal, here's roughly what we think good answers and good executions of this task look like. Here's what we think bad executions of this task look like and where we think the frontier models are falling short. Like, can we just go off and RL something to at least try this? And we'll do that, and then often they're very pleasantly surprised, and they'll plug that in, and that's kind of the traditional world of post-training. Like, you do this big training run, and they'll deploy a model, and it will serve like as this kind of static snapshot of the training that you did. And then I think we're moving to a much more exciting world of, okay, we've done this initial training, like what would it look like if we were to actually really couple this specialization with the inference that we have? And this is one of the reasons I love working at Baseten, is because you're able to do this kind of coupling with inference. So instead of treating training as this one-off run that you're going to do, it becomes, okay, I'm getting this continuous feedback signal from the users actually using my model. Can I plug that into some form of online RL so that, you know, instead of my model getting better every 3 months when I decide to do a training run, it's getting better every 5 hours. And this is exactly what Curse has done really well. Like, big RL training run to start off with for Composer, deploy that model in production, collect more signal from users who are happy or not happy with the answers, and use that to update the model. And they do it every 5 hours, which is quite impressive at the scale that they're at.
So I'm curious as to why can you specialize an open source model in a way that you can't with a closed source model?
Yeah, so if you want to specialize a closed source model, and it's not like OpenAI and Anthropic have never offered these solutions before, like they have offered, you know, a fine-tuning API where you upload a JSON data set of input and output, like prompt completion pairs, and they will fine-tune it for you and then send you back a specialized version of, you know, GPT-4o or 4 Mini back when like this was a big thing for them. But like learning is so much more than either completely pure supervised learning where you simply have those like, you know, input-output pairs and you're learning to predict the next token on the output pairs, or pure reinforcement learning where you have some sort of judge or way to assign a reward to a rollout and you're updating the model based on that. The hard part about like our jobs and like training in general and learning in general is that the algorithm is kind of commoditized now. Like anyone can really write a gRPO loop or an SFT loop. And of course, it's like nice that OpenAI has given a way to be able to run that on, you know, some of their smaller models. But the hard part is really like, how do you marry the customer or the person's like expertise and opinions about what's good for that task with the reward signal in the first place? Like, how do you even get what we're going to learn from? And to be able to do that, like you enter this very messy world of things that sit in between on the spectrum of pure SFT through to pure RL. And so those are things more like, you know, on-policy self-distillation where a student will generate its own rollouts and its own attempts at a trajectory. And then the teacher will be the same student, but just given like extra privileged information. It's like, okay, you could, eventually this might be put in an API, but it's definitely not there yet. And so it's not only like these algorithms that sit in between on the spectrum, it's also, yeah, where is the reward signal coming from in the first place? Like if you're a legal company or you're going to start trying to reinforcement fine tune through OpenAI's API, yeah, of course, okay, you don't have to write the gRPO loop anymore, but like where do you even start from what is going to be the judge or reward model for like, did this model do a good job at drafting this document or not? And so that's the really hard part, and it's what takes up most of our time from like a manually intensive perspective.
I want to talk more about the details around how open source models work in terms of like the fine tuning, post training, specialization. Like, can you break down what some of these terms mean for someone who doesn't know?
Yeah. So we typically start out with, you know, this relatively large language model that has gone through a lot of pre-training where you take the whole internet and you just get it to predict the next token and we teach it to do that. Mm-hmm. And then a lot of mid-training and post-training, which looks a lot more like, okay, now that we have a language model that can do some things, let's one, teach it to respond in like this chat style format. And then two, let's put it in a bunch of reinforcement learning environments where it's going to attempt to do things on its own. And instead of telling it exactly what the correct next thing to do is, we're just going to wait till it's finished and tell it whether it did a good job or a bad job. And that's essentially like the reinforcement learning that comes at the end that has given us these kind of reasoning models that everyone has become so excited about. And that's what you get given when you start out. And that process is exactly the same whether it's an open source model or a closed source model. Like these recipes are largely like agnostic between those two. But of course, as we kind of talked about, what you can do is because we have the weights of the open source model, we can do whatever we want to them. We can keep learning with those weights. Whereas, if you're calling Claude or ChatGPT, the only lever of control you have is the prompt that you provided or the scaffolding that you put around the language model. And so when we talk about specialization, and there's a lot of synonyms for this, it's specialization, it's fine-tuning, it's post-training, and largely, to a large extent, these are all the same thing. And then you have many different options in front of you in terms of how to teach it. So the simplest option and what people used to do is just continuing to do next token prediction with that model on the data you care about. So you get it to predict the next token based on everything that's come before. It might be in a legal domain. You're getting it to predict, the next token in this drafting document. And then we tell it whether it was right or wrong, and we slightly update the weights based on that. Again, you can also move to reinforcement learning, which is where if you have some way to tell whether the model did a good job or a bad job at a task, not just at a token level, but overall. So maths and coding are a great example of this because, for maths, we know what the correct answer is. We're able to verify. For coding, we're able to run unit tests and see if they pass. And so the reward becomes, okay, did this bit of code that you wrote pass all the unit tests? Or did this proof that you wrote compile in Lean and it passes the formalization checks? And so in that way, we can then say, okay, based on all the steps that you took, language model, if you did a good job, we're going to upweight the probability of those steps that you took there. And if you did a bad job, we're going to downweight the probability. And over time, that gives you a model which is able to learn in a very different way from supervised learning, which is very much, I'm just going to copy the next token and learn to predict the next token of whatever distribution that's coming in. With reinforcement learning, it's much more exciting because people believe it induces these more general reasoning capabilities in the model. Basically, you can think of this as kind of how the old AlphaGo and AlphaZero models work. So chess is a great example where reinforcement learning works from scratch because at the end of a chess game, you always have a reward. You either won or you didn't. With language models, we had to get them to the point where, obviously, if you took a randomly initialized transformer, it's not going to ever really give you a correct maths proof. You'd have to sample from it for a very, very long time before you got anything near a correct solution. So reinforcement learning is an inefficient thing to do when you don't have a very good base model. But once you have this base model that has a general world model and a good understanding of the world and is able to sometimes get the right answer, then reinforcement learning can take those right answers and upweight their probability and then downweight the probability of when it doesn't get the right answer. And that's another way in which you can specialize. And then there exist a lot of solutions in between this. So one thing that is wrong with supervised fine-tuning is that the model is very off-policy. And by off-policy, I mean it's never making attempts by itself and then getting some sort of feedback at the end. It's always copying, a teacher distribution or the distribution that you give it to train on with next token prediction. But it is a very dense signal because every single token you're getting a new signal about whether you did the right thing or the wrong thing. Mm-hmm. With reinforcement learning, it's the opposite. It's very on policy, which is good because you're able to learn from your own mistakes. You're in your own distribution. I think humans are very similar. The way in which you learn best is often by doing something and getting feedback at the end rather than rote memorizing things. But it is very sparse feedback. So you only get this scalar feedback right at the end about whether you did the right thing or the wrong thing. Mm. You don't know where in your whole rollout or reasoning chain was good and where was bad. All you know is that by the time you got to the end, you did a good job or a bad job. And so there's a lot of methods that are trying to kind of bridge these gaps and say, how do we give dense feedback, but with on-policy generations? And so something like on-policy self-distillation is an example of this. So we take a model and it will generate its own rollouts. And instead of saying, okay, this rollout is just good or bad, we might have a way to, provide more than just that scalar feedback. So in the context of a maths proof, it might be a larger model with access to the correct proof saying, okay, here is all the bits that you did right, here's all the bits that you did wrong. And then we say, okay, what is the probability of everything that the student did under this big teacher? And what was the probability under the student? And can we move the student closer to the teacher? And so there's a lot of exciting areas that people are pushing in on this to try and bridge the opposite ends of the spectrum of SFT and RL. But I think the point at the end of the day is that once you have a base model, there's many different avenues you can take to specialize it and to teach it your specific distribution that you care about.
Yeah. Yeah, it's really cool. It seems like a lot of people don't know about that yet, but I think that is in part because open models only got good enough around a year and a half ago. Is that right?
Yeah, I think you do need some base level of intelligence in order to be able to like tackle meaningful tasks. I think structured document extraction and very small tasks open source models have been able to do for a long time, particularly if you fine tune them. But only recently are we seeing people start to think, okay, maybe this more broader task that I didn't really consider open source models for before, I might actually be able to teach it to do. And I think this manifested at first in people with all these big sort of agent harnesses often have a main agent, which is kind of like an orchestrator, and that orchestrator is calling a bunch of sub-agents. So it might call a sub-agent specifically for search. And I think last year when we were at Parsed, like people started to think, okay, what if I could get my sub-agent that's doing search to be an open source model, and I can RL it to be really good at search. And search is a great example of this sort of quasi-verifiable domain where RL will work really well. But now, because of like kind of the pressures that I talked about before in terms of people, you know, looking to not be Anthropic wrappers anymore, they are starting to think, okay, what if I could drop in a trained Kimi or a trained GLM and it could do my main agent task? It's not like these models are tiny. Like Kimi is over 1 trillion parameters. Like, you know, we don't know quite how big GPT 5.4 and Opus are, but probably in the realm of like, you know, 5 trillion parameters. So it's not crazy to think that a specialized Kimi could compete with those and even outdo them. And like Composer is a great example of this. Like in many ways, like the model UX of Composer, and depending on which benchmark scores you look at, are around the level or perhaps even better than Opus 4.6. And so it just goes to show that like there do exist very large open source models now with the baseline level of intelligence that would enable you to tackle very complex and very open-ended tasks if you train them in the right way.
So you talked about how they can be competitive, like with closed models. Are there other benefits?
Like over the last year, let's say that the number of flops for inference in the world has gone up like about 3 times. And let's say a conservative estimate of, you know, the demand for inference tokens has gone up 10 times. By many estimates, it would be larger than that. But like we're starting to see that point where those like curves cross over. And now you can no longer afford to just like throw your task at the biggest possible model, biggest possible base model, and just kind of take advantage of that consumer surplus and the intelligence you get from that. Now you say, okay, I have less GPUs than I need to run, you know, this biggest possible model. Like, what is my other alternative? Well, I teach a smaller model to do this like faster and cheaper. And so like, I guess those are the other benefits. Not only if you specialize, you can get to a quality bar that's higher than the frontier models, but also you can usually get a much smaller model and hence a much faster and cheaper model to do the same thing. And so now that we're spending as much money as we are on, you know, API credits for OpenAI and Anthropic, like companies really starting to consider, okay, maybe we should be doing this in a cheaper way.
Yeah, it's so expensive. That makes sense.
Yeah, and there's examples as well where like latency is really important. Like I think in like medical context, for instance, like, you know, ER notes and like pulling information and summarizing it for doctors there, like latency is a super important like axis to consider for those sort of applications. And like if you're relying on the intelligence of Opus 4.6, which is fine, but obviously like it's much slower because it's a bigger model, and also like Anthropic's reliability has not always been the best. Like if you want more reliability and a much faster model, then you would start to consider something that's smaller and specialized and hosted on very reliable inference like Baseten.
You talked about latency, like with closed models, you can't really optimize for like latency in a certain way as opposed to open models.
Yeah, so with closed models, like you have to trust like whatever inference engineering that OpenAI or Anthropic has done behind the scenes to serve their, you know, family of 3 models to millions and millions and millions of people worldwide. You also have to accept the uncertainty that comes with that, in the sense that like you are going to be sending a request and many people will be sending a request to those same GPUs at the same time. And like your latency or your end-to-end time to last token is going to very much depend on who else is using it and how much they're using it. You have no control over that. Maybe you can get, you know, like these kind of like enterprise partnerships or whatever, but for most people that's not an option. With someone like Baseten, for instance, like you have complete control over like how many GPUs you want this thing hosted on. You have complete control over the auto scaling and the concurrency and the utilization and everything like that. And you get access to, you know, these world-class like inference engines that have been highly optimized to run your model as efficiently as possible, as correctly as possible, as fast as possible. And so like the levers of control are much more there. Whereas like, you know, Anthropic's a black box. We don't know how they're going about optimizing things. We don't know how they're making decisions about how much money to make and then thus how fast or slow to serve the models. how many people to serve those two in parallel. So it's another, I think, axis of control that you get taken away from you if you're going with closed source.
Okay. So if I'm building something, you said earlier that first I should actually just start with a closed model. And then you talked about some of the criteria for like when you might switch to an open model. But I'm curious, like, what are the downsides of open models, or maybe what are the reasons why someone actually wouldn't want to use an open source model?
Yeah, I think it all comes down to the beginning. Like, I think it kind of goes back to that top-down approach, right? Like, you should be seeing if at least the best model in the world that out of the box, which is the closed source models, are capable of doing your task. And can you shape that thing in a way which is like, 80% good on that task? And I think if you're trying to do that with open source straight off the bat, like, you can run into problems. Like, particularly if you don't quite understand the contours and the minutiae of like, okay, this particular open source model is good at this thing, it might fall short in this regard. And also just like hosting these things in the first place, like based on where you're calling these open source models from, you can get very different results. Like, people really quantize these things heavily. There's often, like, if you're not very careful and you're not very good at inference, like there's often issues with like the kernels and everything that sits under the hood, and like that just creates complexity you don't need when you're starting out. Like, the great thing about Anthropic and OpenAI is they have 2 or 3 models, and they're very good at serving them, and then they know they'll be served correctly, and all you have to do is worry about prompting them. So just getting off the ground, like, I am a big proponent of, you should just see if the best possible model out there can do your thing. Mm-hmm. Then you work your way down. You say, okay, what about the level below that? I know Opus can do this really well. What about Sonnet? Can Sonnet do it just as well? And then maybe even Haiku. And then you say, okay, what does it look like if I specialize an open source model now to do this, or at least try an open source model? And by then you've understood, like, the contours of your task to an extent that you probably could plug in an open source model and understand at least what it's doing differently from Opus. What it's doing worse, maybe what it's doing better. And that gives you a good ground to start shaping these rewards for things like reinforcement learning.
Okay, very cool. So will open models ever catch up to closed models? I think I read that they used to be 18 months behind. Now it's more like 3 months. But I'm curious your thoughts on this question of, will open source models ever catch up to closed source?
I think I have different answers to this question over different time horizons. So the first shorter answer, like over a shorter time horizon, the answer to me is like, probably not, to be honest. Like, the base closed source models will always kind of be a little bit ahead of the based open source models. I think that's for a bunch of reasons. I think it's in terms of how VCs allocate compute. I think it's in terms of, GPU blocks to China, and a few other reasons. But I don't necessarily think that matters as much as people say it does. Like, to me, the more interesting the question is not, okay, how close are the base models to each other? But because you have the advantage of specialization of open source over closed source, the question is like, what is the intelligence ceiling of this model if it were to be completely optimized for this task? And again, with closed source models, the lever that you can pull for optimizing is prompting. And for open source models, it's prompting plus supervised fine-tuning plus reinforcement learning plus all these things. And so, like, the question you should be asking is, okay, what is the intelligence ceiling? And for me, like, the intelligence ceiling of specialized open source, if you allow yourself to specialize a particular copy of a model for each individual task, probably now almost subsumes that of the closed source models. I think there's a few areas in which just raw intelligence and size is always going to be important. Things like scientific discovery, maths proofs, things along those lines are going to always belong in the domain of the biggest model. But for most economically valuable tasks that I'm seeing now, like, I would struggle to find something in which a really well-trained, Kimi would not be able to at least compete with, if not outperform, some of the, or all of the closed source models. And so it doesn't necessarily matter if the base model is like slightly worse. I think we're now at a point where we've crossed this threshold such that most tasks that people are caring about and building businesses around right now are able to be done by open source models. And so I think open source has actually done a really good job of hanging in long enough to reach that threshold, such that now that specialization is going to become a much larger thing, they're going to remain to be very, very useful for all the reasons we've talked about before. My longer term answer to this is, I think it's a very discrete thing. It's not like this continuous straight line. Like, I think with the new GPUs that NVIDIA is bringing online and the fact that the closed source labs are going to have priority over those, and that's going to allow them to train, MOEs which are 5 to 10 to 15 trillion parameters larger than the ones we got now. I think that there are going to be these discontinuous jumps as open source struggles to get the compute to keep up with those scalar training runs. But I also am a believer that like, yeah, scaling laws hold, but there's like a bunch of inputs to the scaling laws. There's not only model size, but there's also data. And I think that at some point you kind of run out of data, and people have said this for a while. But like when you get to 20 trillion parameters, I think that the bottleneck is no longer the compute or the energy to run the compute. It's what do we actually put into this thing that is actually going to learn more than just like repeating over the same data that we've curated over the past, 8 years at Anthropic. And at that point, I think like if you've run out of, environments to buy from a core or random esoteric books to find and put into the pre-training data, then the big advantage is like very specialized data. And then I think that actually swings the kind of pendulum back in the favor of open source, because again, you're going to have these companies who are like, okay, the only advantage we have over the closed source labs is our specific data and our real world user signal on this very specific task. Sure, it's not for everything, but at least I can make use of this. And like, maybe I don't need a 20 trillion parameter model to do this. And we're now at the point where I think, the 1 trillion parameter models can do a lot of the useful things that we care about. And eventually like the compute will get commoditized again. And of course, like NVIDIA will bring out a new line of GPUs and they'll make Rubin CMOs, but like open source will have access to Rubin, and we might have, 5 trillion parameter open source models, which will raise the intelligence ceiling yet again. And I think as long as open source hangs in there to the point where we can basically do everything that we care about in the world today with a specialized open source model, I think then that's a healthy dynamic. I think the closed source will still have a lot of areas where the most intelligent and largest model will win. And I think they'll accrue a lot of benefit from that, as they deserve to, because they've put so much into the CapEx to build out and the R&D to build out those models. But I think that open source will be the backbone of a society where, a lot of people are serving specialized models to do very particular things.
There's a lot of talk about LLMs replacing jobs, but it seems like because of the rise of open models that we're actually creating jobs like in the inference space. Like, is this accurate?
I think, yeah, like it's certainly accurate in the inference space. And I'd probably push back on people who say that, LMs are taking jobs in general. I think there's been a bunch of scare pieces published in like the last year or so, like the Citrini piece and AI 2027. And a lot of these are talking about the fact that like as AI takes up more and more of like current human labor, then the value of human labor goes to zero, and you get these like inflationary effects and deflationary effects, and everything kind of goes off, and it's not very good for the economy. But I think this assumes a world in which like, demand is fixed and there's like a fixed slice of the pie. And historically, if you look at what's happened with like any advent of any new technology, this has like never been the case. Like when the internet came along, or like computers came along, we didn't just like automate like manual clerking and like all the things that we were doing back in the 80s and 90s. Like it also fostered a whole new ecosystem of jobs, which like opened up what people could actually do. And so I think this argument of, okay, LMs are going to take human labor and that's going to be a fundamentally bad thing is not necessarily the correct framing. I think it's going to look more like, yes, there will be like some short-term pain as jobs that we know it today that are readily available to many even skilled workers are replaced by LMs. But I think that the capacity that frees up and like the jobs that creates in the long run are going to be a repetition of everything that we've seen in the past. And like humans have historically been very good at figuring out what to do when, very manual and labor-based tasks have been replaced. And I think that will be similar for like cognitive-based tasks. I think inference engineering is a great example of that. Like one of the perhaps fastest growing areas in the world with one of the highest ramp ups in complexity. I think that, when this first started, this LLM boom first started, and we had very vanilla GPT style models, inference engineering was hard enough. But as researchers got more and more wacky trying to figure out ways to make these models smarter, Mixture of Experts is a great example of this, where we have a much bigger model with many more parameters, but we only activate some of those parameters every time we call it, based on which experts we decide to route to for this particular question or this particular token. That's a really hard inference problem. And that's certainly much harder than the vanilla dense models that we had back in 2019, 2020, 2021. And so as these like models get smarter, like it's a really concrete example of an area where there's just going to be more and more jobs as we figure out like how to manage these things. And like they're very like cognitively demanding jobs, sure. But I think like that same pattern will hold through like a lot of the rest of the economy as well.
Yeah. So you talked earlier about your learning approach and kind of top-down learning. For someone like me, kind of just a regular software engineer, and I want to get into inference engineering, what could be a good like first step or first project for me?
Yeah, I think actually the way that inference engineering has gone is a really good example of that top-down approach that I've been talking about. So in the old days, to like be a really good inference engineer, I think you did have to start from the bottom up. Like you had to learn like CUDA, you had to learn how to write kernels, you had to learn how to like plug that together into like some sort of inference engine with queues and continuous batching and all this sort of stuff. I think nowadays it looks much more like there are solutions that exist out of the box where you download VLM and you download a model and you load it up and you can just call it. Like it can generate it at like reasonably fast speeds. And so now the problems are shifting towards, okay, like now that I can get this thing running again, which is the top-down approach, like can I just get it working in the first place? Then you start to think about the optimizations that can be made around that. And so I then start to think about, okay, I don't have to learn how to write kernels immediately, but okay, like I'm now in this agentic system where the prefill is dominating much of my time and the decode doesn't matter as much. So like, can I learn about things like KV cache management and shuttling that around and like networking stability and all those sorts of things. And then maybe eventually I get to kernels. But like at the end of the day, like VLM, TRT, SGLang, these are all inference engines which are able to run models out of the box, but still require a lot of work and understanding to make them as good as possible and reliable as possible. And that goes for a very high level in terms of like, playing around with like speculators and eagle heads and things like that through to like, the other day someone found this massive bug in TRT, which meant that mixture of experts was getting routed incorrectly. And like that actually got found by like someone playing around with it internally at Baseten. So I think like, yeah, the fact that you are able to get inference working out of the box is like pretty lucky. Like when I first started on these things, that certainly wasn't the case. But it enables you to go top down in a way that you couldn't before.
So you co-founded Parsed and you were acquired by Baseten, which is how I know you because I work at Baseten. So can you talk about why you chose Baseten and how this happened?
Yeah. It was funny. The first meeting we had with Tuan, CEO of Baseten, was we were trying to sort out our inference provider for Parsed. Like obviously we would train models for customers and then we needed somewhere to put them. And so we talked to all the big inference providers and we weren't really that happy. And we walked into the Baseten meeting. I was visiting a customer in Australia at the time, so it was very early for me. I think I was basically still in my pajamas. And Moody told me, like, we got to play a bit of hardball with these guys. So, like, you go in and play a bit of hardball.
With your pajamas on?
With my pajamas on. And I remember asking Tuan very distinctly, like, if he could handle our volume, which was, like, such a ludicrous thing to ask for, like, a seed stage startup with, like, barely any customers. And Tuan just laughed at me. But, like, I think the relationship grew from there. And, like, as we realized how good Baseten was and as we grew alongside Baseten, like, we made them our sole inference provider because they offered many things that, like, none of the other inference providers could. And then I think eventually, like, Baseten started to notice that, like, customers were just appearing through us on the Baseten platform and they were all using specialized models. And, like, I think maybe some of them Baseten had tried to, like, kind of work with before. And Baseten is the best in the world at inference. And we thought we were really good at post-training and getting people off closed source models onto open source models. And so eventually at some point, Tuan was sort of like, why didn't you guys come do this with us? Like, I think the customer doors that are going to be open are going to be like 10 times larger. The demand is clearly there. And then if you couple yourselves with inference, like it's a no-brainer. And for us, this solved a really difficult problem of like feeling like we were this awkward middleman between the customer and the GPUs. Like once you trained a model for a customer, like theoretically they could just go off and deploy it on their own GPUs. They could go to Baseten directly and suddenly there's not really like a proper business model there. And for Moody and Max and I think all we cared about at the end of the day was like this problem and like solving this problem. I don't think like we necessarily felt like we needed to be our own independent startup or company in order to be able to solve it. And we're very lucky that we've been able to retain the autonomy and, make the research bets that we want to make and like have the compute that we need at Baseten. And like Tuan and Amir and Phil and everyone have been really supportive of that. And so, yeah, it's kind of the best of both worlds. And I think it's been a win-win for showing how training can be coupled with inference to give something much more powerful than like either of those two things by themselves.
I think many people in the AI space, like Dario, for example, have argued against open source models for safety reasons. And I'm curious your thoughts on that.
Yeah, I think like people like to talk about very specific examples here, like building bioweapons and X risk and all these sorts of things. I think stripping away the superintelligence argument for a second, the thing I worry most about with AI is not how a small handful of bad actors will use this in very specific scenarios. I think it's the fact that a concentration of power without accountability has always been like the most severe failure mode of like any civilization as far back as like we can remember. I think if you do live in a world where one company or maybe two companies and the handful of people inside those companies responsible for making the decisions have all the control over AI, which is like the most powerful technology we've seen, I think that even if you trust the initial actors at the start, if you trust Dario and his vision, it's a very different situation to, some of the technologies we have in the past where there's sunset clauses kind of built in, like the distribution and diffusion of that technology will eventually happen. And I say that for one main reason, which is that the people who control the AI and like once that gets past a certain threshold are going to have the capability to use that AI to extend their own advantage and their lead. So there is no sunset clause built in here. And so I think that's like everything that, Western democracy fights against is concentration of power, particularly power that enables itself to continue its own reign, is like a fundamentally bad thing. Like there's so many checks and balances that we have built into like our political system that we trust to ensure that that doesn't happen. And I think that like if you are buying into this argument of, AI is going to fundamentally change the world, then even if you trust Anthropic now, like I don't think the variance and the risk of incentives and behaviors changing over time is worth having one person controlling all of the AI. And so I actually think the more conservative and status quo bet to make would be to diffuse this technology. And sure, there are going to be short-term pains in terms of like allowing AI to be used by basically anyone in the world. I think like cybersecurity is a great example of that. And again, people are talking about this with Mythos. But I think that short-term gain is like kind of an inoculation to the world against like all the potential harms this is going to have. And it's also going to allow the world to more readily robustify like the existing infrastructure that we have to handle like intelligent AI. It's also going to allow us to build in these defenses with the same intelligent AI to counteract the effects of bad actors. And so, yeah, I like at the end of the day, concentration of power, particularly power that can extend itself, is like not something we've ever accepted before. And the fact that AI will enable whoever controls it to extend their own lead, if it's kept it completely internal, is not necessarily a great thing to me. And so that's kind of why I think that like we should just trust the systems that we have for deciding these things and stick with a more democratic future of AI rather than one where, Anthropic or OpenAI controls it all.
Mm-hmm. We talk about this question of like who controls AI. And some people would say that having the weights, like having open weights, is not actually who controls AI, but it's actually who has the compute power. I'm curious your thoughts on that.
It definitely is. I think that we're lucky where even the biggest models in the world basically run on one node, so like essentially 8 GPUs. Like the great thing about how language models are currently trained is that you need a lot of compute to do training, but to actually serve the model, at least for like a handful of users, you only need a small number of GPUs relative to the amount you use for training. And so yes, like it might be the case that you need a lot of GPUs in order to get to these like large models, but if those are being distributed, then you need much less GPUs in order to be able to run it. So I think that like kind of balances out or like amortizes the compute concern somewhat. Of course, there's like second and third order effects of this. Like if you are able to get access to so much more compute than your competitors that you're able to train, the 30 trillion monstrosity that is starting to approximate what a super intelligence would look like, then that's like a fundamentally different concern. But I think in terms of the setup that we have now, where we're pushing between 1 and 5 trillion parameter models, like you are able to still democratize access to that once it has been trained. And so we just need people who have incentives to keep training and releasing these open source models to continue to do so that like this can kind of promulgate.
Cool. Thanks for being here, Charlie.
Cool. Thanks for having me.
Okay.